Welcome to the Lab 2 tutorial, where we are going to deal with functions and see how are translated the function calls during the synthesis process. So expand the Lab 2, expand source, and double-click to open the C file. So here you can discover the function polynom that we used in the previous tutorials, and another function that has a function call to the polynom. This function is a sum of polynom. So click on Lab 2 and build the projects. So during this build, the setting file will be created. So build again in order to remove the errors. And then go to the debug, expand source, and go to dot in order to open the dot file of the sum of polynom CDFG. So double click this one and open it. And then you can also open the scheduling of sum of polynom. And in these two files you will see the CFG of sum of polynom. So here you have the loop and the exit of the loop, and inside the BB 165 you can see that the function call of polynom is translated into an operation node called polynom, and we have all the other operations in the input C file. You can see the scheduling trace, which contains the scheduling and binding of the operator polynom that executes this operation. So now, as for the first examples, we are going to simulate in order to validate our sum of polynom function. So go double click on the setting file, expand until arriving to the sum of polynom function, click on it and turn the generate test bench option to true. Save and build the projects again. So now open the test bench VHDL file in Model Sim and execute the simulation as we saw previously. So Tools, TCL, Execute Macro, and look for your VHDL projects and double click on the makefile_lab2.tcl. So this will launch the simulation. So change the runtime options into decimal, apply, okay, reduce the window, and then you can check if the computation is correct. So remember that the input of sum of polynom is the size of the loop. For example, if size is equal to 1, we only do one call to the polynom function with the value 0. That's why the result here is 1. So here the size is 2, 3, 4, etc. So we can verify that the computation is correct. With this example, you have performed the hierarchical synthesis using function calls. So thank you for listening.